Good morning, everyone who is here a little early. We are about ready to start. Give another minute or so for people to filter in and just make sure you're in the right place. Heat pump deep dive. If you didn't mean to be here, you can stay anyway. It will be very interesting for you. All right, here comes some more people. Kristy is literally bouncing, ready to go.
Oh, I am. The best and worst invention of all time is those like giant exercise balls, and
Yes.
I can hold still, but that kid in class, I was like always clicking the pen or spinning the thing or playing the was 100% me. Now I bounce.
Both my kids, so I am used to it.
You know, I taught I was in a classroom for 15 years, and
Oh,
I wish I could say like it used to drive me nuts when my kids did that, but honestly, I was like, I get you.
right. Yeah.
Yeah.
Okay, well, I want to talk to you more about that later. It is 10 o'clock, so let's get started, everyone. Welcome. I am Katie Sealing with the Lighting Design Lab, who some of you may know. If you don't, this is who we are, Lighting Design Lab. We're a part of Seattle City Light, and we've got DNR Learn here today, Lester and Kristy, presenting a heat pump deep dive. We had a heat pump water heater deep dive last year, so this is a nice complement to that. Let's see, let me see if I can switch my slide here, just in case you haven't taken a webinar with us. You're going to be on mute the whole time, but you are more than welcome to ask questions in the chat. It may look like this enter question for staff box. It may look like that little question mark in a bubble, depending on which way you've logged in. The webinar is also being recorded. We started recording at the beginning, and we'll post this recording within about a week of the end of class. There's a little survey afterwards to give us some input on how we can improve, so please take that if you've got time. And just to let you know and remind you, this is a 2-day course, so if you want to take the complete course, make sure you're signed up for that day 2 on Thursday. And then we are excited to have electrification of the built environment coming on the 18th and 20th. We haven't offered that one yet. And then in November, we've got another one that we haven't offered yet, overcoming, this is the mouthful, overcoming installation sales challenges for residential replacement heat pump water heaters. So back to water heaters. And then in between there, if you're in the Pacific Northwest area, specifically right around Linwood, there's going to be a hands-on workshop on October 25th. So you'll get to play with some products. Okay, without further ado, let me hand this back over to Lester and Kristy. Here we go.
Yeah, good morning. While Lester gets that all queued up, welcome to Heat Pump Deep Dive. My name is Kristy Podelnyk, and I'm here with Lester Terrance to talk about all things heat pump. And in the background is our talented moderator, Jordan McCarthy, who's going to be assisting in all things technical. So when you come into the chat, he'll be attending to that to make sure we are answering your questions. When we're like, we're going to give you a link, Jordan's the one doing that. So really, really thrilled to have a great team here. And before we get started, let me tell you a little bit more about DNR Learn. It's the educational arm of DNR International. And I'm going to read this so that I don't get it wrong, but DNR International connects people, data, and technology to transform markets and build a sustainable future. So the role of DNR Learn then is to have a lot of innovative conversations that focus on developing really robust webinars and courses for the folks who are looking to, stay in the know about emerging technology and then energy efficient building technologies. So like Katie said, this webinar is delivered in 2 parts. This part today, the part on Thursday, same time, same place, and we'll be providing you a copy of the deck as well, so that if you want to go back to it and look at it later on, you have something in your hands to return to. You can expect our webinar today to run its full length from 10 to 12, but we will be taking some breaks to answer questions, to just take a breather, a break in the middle, a longer break for attending to your coffee or biological needs. And then the last thing that I want to mention is we're going to be using some interactive polling software today. It's called Slido. I adore this tool. Like, definitely put your questions in the chat for sure. That's where we attend to those. But this polling software, it doesn't track any of your personal data. And what I really value is that it lets us engage with you in kind of a different context. You know, you're muted, you don't have your camera off right now, you don't have your camera on right now. So it's hard to know if what we're doing is answering your questions or meeting your needs. And Slido, the software, lets us do that in really useful ways. So I would really, really value your input on that today. We really value your input on it tomorrow, Thursday, when we see you again. Please take advantage and engage, because we definitely want to hear what you're thinking, and we definitely want to meet you with what you need. So just to kick things off and make sure that everything is working right, would you mind just throwing like a good morning or a hello, or I'm on my 3rd cup of coffee, whatever you want to say, into the chat, so we know that we're able to engage with you that way. Just a quick like, what's up, whatever you want, just so we can make sure that the chat is working. And while you do that, Lester is going to introduce himself. Lester?
Hey, Kristy.
Hey.
All right, let's get into this. I do apologize today. I'm unable to cut my camera on. I'm having some camera and application issues. But there is my face right there. My name is Lester Terrance, and I am an HVAC instructor and instructional designer with DNR International. I have served in the United States Air Force for roughly 12 years, where I began my Air Force career as well, but also my HVAC career, and then served another 7 years with the Department of State as a subject matter expert, bringing me to close to about 20 years of HVAC experience. I am a licensed master HVAC in the Virginia region or area, and I am currently speaking to you all from Bowie, Maryland. So I know a lot of us are on the West Coast right now, but I am currently on the East Coast providing my portion of training for you. Yes, that covers my background and introduction, and I'm happy to be here this morning going through this heat pump deep dive with Kristy, presenting it to you. So I think she is up next on her introduction.
Thank you to everyone who threw something in the chat. Appreciate that, or into the questions. Yeah, my name's Kristy. Here are the deets. I am the lead content developer and expert in commercial heat pump water heaters for the DNR Learn line. If you have seen some type of product or tour or PDF or infographic out there about commercial heat pump water heaters in the last couple of years, it's probably something that I've developed. I am the instructional design team manager, so in addition to doing instructional design and building products, I also manage the team that builds product and content for the other courses, like that electrification course that's coming up. It's amazing, and that was my team that developed that. And then the implementing the residential heat pump water heaters, that was also part of our team. Really, really incredible stuff, and really great classes. So you should definitely sign up for those. I am a nationally board certified teacher, and I have over 15 years of experience in education. Before that, I spent my time working in molecular plant sciences, so my background is in STEM. And then through like a series of really interesting events, ended up in this position, which I love, and just had an opportunity to go and explore some heat pump water heating applications in dairies and in rural districts, which is super cool. So some neat stuff to share about that today too. So yeah, that's me, Kristy. I'm going to do a lot of talking up front, and then I'm going to fade away into the background as Lester's going to take the lead today, but you'll see my face again tomorrow or Thursday when I see you again. So let's talk a little bit about how this course is set up and what it looks like. Today, we're going to tackle a couple of big ticket items. It's the top 3 bullet points you see there. The what, the how, and the why of heat pumps. We're going to look at really like, why are we here? What is this thing? And how is it being used? And then Lester is going to spend some time talking about the evolution of heat pump technology into the role that it is currently in today, how it's being applied, how it's being used. And then we'll spend some time also like looking at, and I love this, it's at the end of our webinar. Lester will spend some time talking about applicable codes and things to be thinking about. And then on Thursday, when we get back together, we'll look at heat pumps specifically in domestic hot water applications, essential considerations for the use of that technology in that application, and some successful case studies of that. So here is the first survey, that like interactive polling software that I was just telling you about. We want to get to know you a little bit better so we can speak to your needs. We can see where you're at, meet you with what you need to. You know, you have a limited time with us today, and we want to make sure we're attending to your goals. Slido.com is where you can go. You can open up a new tab on your web browser if that's how you are joining us today, and go to Slido.com. And in the event code, enter in heat pump. Jordan is also going to be posting the actual like web link into the chat. Another way to interact is to grab your smart device and just scan the QR code in front of you, and it'll take you right to today's surveys and polls every single time we go back to it. Again, what I love about this is it doesn't track your data. You don't need a login. You can do it totally anonymous, and we get to hear you, which I think is really, really valuable. Let's go ahead and open up the poll, Lester, on the next slide. It has all that information, by the way, like we're not taking it down. So we have a couple of quick questions for you about how's your day going, about your experience. And as you fill that out, I'm going to banter a little bit in the background. It's not important. It's just some background noise as you fill it out. But Lester, how are you doing today?
I'm doing well. Another day in paradise. How about you, Kristy?
What's the weather like there? Has it gotten chilly?
It has, but today's actually a pretty nice day. I think we're going to be in the 70s today, which is
Oh, that's perfect.
Yeah, it's perfect weather. How about on your end?
Huh?
How about on your end? What's the weather looking like?
Yeah, that's so I'm on the other side of the country. I'm in the Portland area, and I think it's going to be a gorgeous day too. And I just spent we just had this beautiful weekend that like quintessential fall, which was awesome. It was really, really wonderful.
Yeah.
I definitely appreciate it. I'm not a cold weather person per se. I've lived in a lot of cold weather places, but I like the heat, so I have no complaints.
Yeah, I do too. But you know, growing up in New York, something about that cold weather, that fall, December approach, I like it. I like jackets.
Oh, you?
Yeah, I like jackets.
I tend to wear mine around the house, and it's not that we even get it that cold. I do like to turn my climate control off for a little while, and then because I feel like you can just put more layers on.
Yeah, that's what I know. I do it here all the time. Like right now, I literally do what I used to do out in the field at home. I put the whole house in no heat, no cool mode.
Oh, well, looks like we've got 3 people. I'm looking in the upper right hand corner, or not 3, 13 people. Thank you so much. That is thank you. That is fantastic. Let's go ahead. Let's go to the first question and see how folks are doing. Okay, so how you doing today? Great, I'm here for it. Love that. Good, I'm easing into the day. 2 solid answers. Only a small percentage of folks who are like, huh, where am I? What is this? Which,
Still need that coffee.
Yeah. Let's move on to the next one. Thank you for letting us know how you're doing. I'm really glad the majority of us are in a great place. What do you do and how long have you been doing it? We have a heat pump design engineer, 20 years of energy efficiency in schools and homes, but really interested in getting my dinosaur schools closer to net zero. Oh, I have some stories about schools. Yeah, I feel that struggle. Energy engineer for 5 years with mechanical HVAC background, a professor of 23 years. Lester, you know what I love about this question, and you can scroll down if you'd like so we can see more, is that I feel like we get a little bit of everybody here, like some people who are starting out, some people who have been here for it, and I really value that because of the different perspectives that we can bring together for this conversation. You know, like from someone who's fresh out of school to someone who's like been in their position and they're ready for their next step, an architect for 25 years, an energy analyst. Awesome. So excited for the folks who are joining us. Thank you. Let's move on to the last question, to rate your current understanding of heat pumps. And I see in the chat that someone asked, is this all domestic hot water related? It is not. In fact, all of today is going to be about heat pumps for comfort heating, cooling applications in both the residential, multifamily, and commercial settings. And really Thursday will be a closer look at domestic hot water applications and again, residential, multifamily, and commercial settings. So rate your current understanding here. We have lots of dabblers. So I wrote this question like, I know some, but I've got room to grow. What I should have written is, I know just enough to be dangerous. Right? Yeah. Oh, thank you everyone for participating. I really, really appreciate it. So we've got a lot of dabblers. We've got a number of learners. Really, really excited. Super easy polling. We really, really appreciate that. And then the last one, what questions do you bring with you today? Full disclosure, we're not going to answer all of these right here and then, but we are going to keep that on the back burner so we can see the analytics on the back and hold these in our mind's eye so that we can make sure to address them. Are there new options beyond the SAN code 2? That's great, great question. The codes and standards required to design and test the heat pump water heater. Looking for air to water heat pumps. Ooh, we're gonna, okay.
I think we touch on that briefly, yeah, but not too in depth.
That's a good one. We'll look and see what else. I have some examples I can share with that person. How to keep auxiliary heating off, looking into the latest application and real world uses, all the questions, and how are manufacturers preparing for refrigerant phase outs? Those are great questions. And I think I think we addressed most of these in our webinar today. Lester, what do you think?
Yeah, I think we've got a good bit of it that could be addressed today. But the second half, you definitely want to be there for that, just in case those of you who have asked questions that are here that doesn't get answered today, it more than likely will be answered on our second half of class, especially on the coding portion as well. There's 2 parts to it, today's and Thursday's.
None of these look like to me questions that we totally ignore. I will spend a little bit of time. So ever asked looking for air to water heat pumps for hydronic heat? I will pull some, I know I have some case studies for that I can share next time we're around. So I'll come prepared for that. Cool. Okay. You ready, Lester?
Yeah, let's get into it.
Let's do it. Let's talk about the what, the how, and the why of the heat pumps. Since we have a breadth of learners here, people who have been in the field for a long time, people who are just starting out in the field, a lot of different levels of expertise, we're going to begin our conversation with some of like the foundational touchstones. So let's make sure we're all talking about the same in the same way and really establish the reason for why we're here. Go ahead and move forward, Lester. We are together today because we know heat pumps are a great solution. We know this for a couple of reasons, and we can boil it down to decarbonization efforts, energy efficiency goals, and then grid stability. And up on the screen, you're going to see 3 images to represent those things. Heat pumps are a great solution because they check all 3 of these boxes. When we start to think about the goals, we know we are experiencing climate change. We know we are experiencing some of the nastier effects that we weren't looking forward to, but this is where we're at right now. And we also know that there have been some really ambitious climate goals that have been set. If you look at the image in front of you, the graph that's shown under or above decarbonization, that was produced by the EIA representing the decarbonization goals between now and 2050. And this is not, so this is for California specifically, but it is not standalone. There are federal goals that are identical to this. So we know that we are setting some very lofty, very ambitious goals for ourselves that are not unachievable. They're achievable if we start to think about our building technologies really strategically. And heat pumps are a part of that thinking, that change in how we provide comfort heating and cooling, provide domestic hot water. So checkbox number 1, heat pumps are part of that. We also know that as we start to move into decarbonization, using less carbon resources, using more electrification, like electrifying our buildings, we really need to be cognizant of how much energy we're using. And so heat pumps check this box as well. They're really energy efficient technologies. You are looking at in front of you, that middle picture is a pie graph, and it comes from a study. It's a domestic hot water application. So this is for a multifamily building. Engineers went in, they measured the energy usage. They found out that the domestic hot water system was accountable for like 25% of the building energy use. They switched out a traditional gas boiler system with a heat pump water heating system, and pretty quickly there were significant energy savings that were realized. About 17% of the energy was saved in the overall building. So we know that heat pumps are that next step. If we're going to electrify, we need to do it really effectively. Heat pumps are 3 times more efficient than electric resistance water heating, and they are carbon-free asterisks there, depending on where you get your energy, right? If you're getting it from your photovoltaic cells, your solar panels, totally carbon-free. So we know that they're a part of that energy efficiency thinking, that energy efficiency solution. And then finally, as we move more towards holistic electrification, we need to be thinking about grid stability, right? That, like, the actual infrastructure and supporting it, especially during those times of peak load. And heat pumps are really great technology in this regard because they have sophisticated controls. So you can do things like load shift. You can do things like duty cycle. You can do things like demand response with these technologies. So 3 boxes checked. That's why we're here today talking about heat pumps, because we know we have some goals in hand. We have some things we have to consider, and heat pumps can be a solution to achieve all of those things. What is a heat pump? Again, let's make sure we're all on the same page here. A heat pump is a device that transfers heat from one medium to another. Those can look different. Heat pumps can be used in a number of different applications, which is what we're going to look at next. But it moves heat from something to something else, versus some of our traditional systems, which are generating heat. That takes a lot more energy, tends to be not as clean. So it's moving heat from one source to another. Next slide, Lester. So let's take a look at how heat pumps can be used. And this is not like the most comprehensive list you're ever going to see in your entire life. This is just a layout of how we have designed and organized the instruction for this webinar. So heat pumps have a lot of applications, some in the comfort heating and cooling side, and some newer applications in the domestic hot water side. When you look at this image in front of you, the left side is different types of applications where heat pumps are used for comfort heating and cooling. So you have heat pumps that can be used in mini split systems. You have heat pumps that can be used in VRF systems. You have heat pumps that are monoblocks. And this is all for your air conditioning, for your heating, So they can be used in that regard. It's, you know, a device that moves heat from one space to another, comfort heating and cooling. Pretty tried and true. Like, I'm not going to spend a lot of time talking on that because that's probably where we're all most comfortable is seeing them used there. But then we have heat pumps that can be used in domestic hot water applications. And this is what's a little bit newer and where people are getting a little, okay, tell me a little bit more about it. So on the domestic hot water side, we have heat pumps that are packaged into integrated systems and can be used for residential projects, applications. We have heat pumps that can be packaged into split systems for domestic hot water applications. And then we have what's newer in the playing field, and what people are really looking forward to is heat pumps in plug and play applications. So heat pumps that are part of a bigger skid design that can just be craned onto or into a building and plugged in, and you get hot water from this heat pump system that's already set up. We are going to spend, go back just for a second, Lester. So today we're going to be talking about the left side of this. On Thursday, we're going to be talking about the right side of this. So if you're ever like, what are we talking about? Today is comfort heating and cooling. Thursday is domestic hot water. All right, now you can go on. So the last thing I'm going to very briefly touch about is applications for heat pumps. So in addition to being comfort heating and cooling, domestic hot water, heat pumps can also be used in residential applications. Heat pumps can be used in multifamily applications. They can be used in commercial applications. So they're pretty adaptable for a lot of the different projects that you encounter. On the left side of the screen right here, we have examples of residential applications. We have the mini split system on the left, and then on the right is a domestic hot water, an integrated heat pump water heating tank. And these, like, you can just plug these into your house. Like, these might be providing your air conditioning or your heating right now and your hot water right now. On the right side of the screen, we have some examples of commercial applications. So the left side of that, the HVAC, those are the Mitsubishi City multi-heat pumps. They're part of a VRF system, which is also, we're going to look at this example because it's really cool. It's also part of the comfort heating and cooling and the domestic hot water system. So these heat pumps are doing both in a commercial application. And then on the right side, we have an example of heat pumps used in a domestic hot water application. And these are the Nile heat pumps. Let me look up what kind, because I always misquote it. The C125A heat pumps used in a project in New Hampshire, cold weather climate. They're doing great, but they are responsible for providing domestic hot water to 60 some apartments, which is amazing that these are so effective. Like, that's how far the technology has come. So we're going to look at all of that, but just keep in mind, you know, comfort heating, cooling, domestic hot water, and then under those you can have residential, multifamily, commercial. Okay. So grab your device. Oh, actually, I'm sorry, I was stepping on toes. Oh no, this one is me. Grab your device, open up your web browser, head back to slido.com. In your opinion, what is the greatest value proposition for heat pump implementation? And that can be heat pumps used residentially, heat pumps used commercially. It could be heat pumps used for comfort heating and cooling, or heat pumps used for domestic hot water. But we'd love to hear from you. What is your biggest value proposition? What's the greatest one? I shared a couple that we like to focus in on, but ultimately you're here for your own reasons, and we'd love to hear that. I see some people. I'm so happy that we have folks participating. Thank you so much. Really, really appreciate it. I see heat pump water heaters, exclamation point, agreed. They're pretty cool. Residential heat pumps, yeah, multifamily residential. I just went through like house buying in the market this spring, which was a challenge. And I think I kind of psyched out my realtor because I was like, well, what, you know, when we're going through houses, they're like, tell me about the water heater, tell me about the air conditioning, like, how are we using it? And I wanted to go look at them. And he was finally like, Kristy, this is kind of weird. And I was like, I think this is responsible. So like that residential application, I get it.
Hey, Kristy, we've got a question that came in. What is VRF?
Lester, you want to get this one?
Yes, we will actually be touching on that here shortly, and I'd like to wait till we get to that part because I want to dive into it and get you to understand, everyone in class to understand the different systems and applications, and not to get confused. So if you could just hang on maybe another 20 minutes or so, we'll dive into that and get you understanding what VRF systems are and what they're available in the commercial world out there to do today.
Good question. This is a good one because we're coming up to it. I see energy efficiency here, better heating efficiency for seasons in cold climates. Hopefully, yes, actually, yeah, we've got some exciting things to share about refrigerants in that regard. In our area, they provide the added bonus of AC. Yeah. I live in an area that doesn't often have AC, but with the last couple of summers, it's becoming more prominent now, and for good reason. Thank you everyone for participating who did. We really appreciate the value of placing electric resistance heat. Lots of energy savings, which can, translate into a lower bill, which I like. Like, boils down to the money, right? Like, I don't want to spend a lot more on it. If I can save money on energy and do good, that's awesome. All right, Lester, let's move forward. Okay, so we know for sure we're gonna tackle VRF shortly. Are there any other questions out there, Jordan?
Not yet.
Okay, keep them coming in. You're gonna see my face disappear. Lester, I'm gonna hand the baton to you so you can start to talk about heat pumps, mini splits, VRF, monoblocks.
All that good stuff. Yeah. But before we do that, we're gonna definitely jump into the evolution of heat pump and the early days of heat pump technology. Excuse me, which is important. Understanding where this technology comes from, because it's not new technology. It's actually been around for a little while. And what we'll do here is we'll talk about that technology and how it's come about and how it's gotten better over the last few years. So heat pump technology isn't new technology, as I've said before. It's actually been around for quite some time. And the original heat pumps were found on the first refrigerators. So let me see if I can get this pointer here to work with me. There we go. So hopefully we can see that red pointer there. If you could look up to the top left-hand corner of our screen, we'll see a refrigerator up here. And this upper left image shows the classic refrigerator from the early 1900s, which has a heat pump seated on the top of the refrigerator. Now, this system here was known as the GE monitor top due to the compressor being mounted on the top of the refrigerator. Over to the right, as technology got a lot better and more innovative, we're able to incorporate our heat pump systems into everyday equipment, and air conditioning systems like the top middle and the top right applications here featured the same vapor compression cycle that we use in the same devices today. So as time went on and technology improved, we were able to take the technology from our heat pumps utilized in our refrigerators and move them slowly but surely into other applications, such as air conditioning systems for the home and also air conditioning systems for our automobiles. And we get a little bit further down into today's time and how heat pumps are being incorporated into different systems and applications. And we can see now that down in the bottom left-hand corner here, we're starting to use heat pumps in everyday equipment such as our dryer systems and also our AC systems, and pool heating equipment will also host heat pump vapor compression systems. So heat pumps have made its way through the technology and its upgrades, and it is now here providing us with an alternate way of heating our homes, and not only our homes, but now we can heat domestic hot water for our applications, where we're also saving money and saving energy at the same time. So let's talk a little bit briefly about how heat pump systems work. What we're going to do here is we're going to talk a little bit about the vapor compression cycle, touch on the major components of a heat pump system, and then after that, we're going to talk about the types of heat pumps that are available out there. And I believe this is where we're going to touch on that ground source, air source, and water source, which I believe we had a question about earlier. But before we jump into that, let's talk about what you're seeing here to the left on your screen, which is an image of an air source setup of a heat pump system. Excuse me. And if you take a look at this system here, what you're going to find on every system is you're going to find four major components, which consists of your compressor, your condenser, your metering device, and also your evaporator. Now, within the vapor compression cycle, what you're going to have is you are going to have a refrigerant flowing through that system. And when that refrigerant flows through that system, it creates a mechanical process, which we'll go over, where you're going to be taking gas and pulling the heat energy from it in order to provide that heat energy to the source that you're looking to manipulate or heat or cool. Now, let's talk about how that process works really quickly. For those of you that are not familiar with the vapor compression cycle, let me know at the end or at our first break, and I can put a link in the chat for you that will get you some more information where you can follow up on this actual process, because it is important in understanding how these heat pump systems work through the vapor compression cycle. Now, what you're going to have in this cycle here is in your evaporator, you are looking to heat, let's say we're using this as a heat pump water heater, you're looking to heat up the water at your evaporator system, or you're looking to pull your heat energy into your evaporator system. So this system is going to be sitting outside. If you had a combined system where your system was both a heating application and a cooling application, your evaporator system would be sitting inside, so inside your utility closet. And that's usually sometimes the point where individuals get confused about heat pump systems working on a combination system where you have air conditioning and heating. But I will make that simple for everyone here today to understand how that is able to work. You actually have an additional component installed in your system, which is called a three-way valve. And what that reversing valve or that three-way valve is doing is reversing the vapor compression cycle, so that way you can have heating or cooling. So let's just go through the vapor compression cycle really quickly, and we'll do it in the way that a heat pump traditionally works, without the actual cooling factor involved. So what's going to happen is you are going to have your evaporator system, which is your outdoor unit sitting outside, and this system is going to be what's responsible for picking up the actual heat that will be delivered to your condensing unit, where or your water tank, or your heat exchanger, where your unit is going to create your hot water. So your evaporator is going to be where you pull in your heat energy, which in this case here you have your air sourced water heater, which is going to be pulling air, drawing the heat from the air outside in order to make hot water. So what's going to happen in the total reverse, if you were utilizing this as a cooling system, is that your evaporator would be picking up the heat that is indoors and rejecting it to your condenser outside. So the total opposite of what's happening in a domestic hot water application versus a cooling application. Now over to the right here, what you're going to see is a graph or a chart containing a water source or water-to-water source of energy heat application. And we'll touch on more of those different sources here shortly, where we talk about ground source, water source, and air source applications. But what's going on here is that instead of this being an air source, such as the image over to the left, what you're going to be using is the only difference is you're not using air, you're going to be using water as your source where your energy or heat is going to be removed from. Now let's touch on the types of heat pumps that we have available. And we did have a question earlier about water source heat pumps, and we'll touch on that here shortly. But you have three different types of sources of heat pumps where you can pick up your energy in order to provide that heat pump to work, in order to make that vapor compression cycle work within that heat pump. So you have your air source, your water source, and also your ground source. Now, this is not a complete list of all the different sources of applications that are out there to provide you with heat pump systems, but these are the ones that you're most likely to encounter out in the field. Now, as I explained earlier, your air source heat pump is going to be one of your more common type of heat pumps that you will see out in the field. And this heat pump can reduce your electricity and heating by approximately 50% compared to resistance heating, where you're using electric heat strips, or even your furnace heating and baseboard heaters. Now, air source heat pump technology has advanced a lot over the last few years to the point where it is now being an alternative in colder regions. I'll just tell a quick story about why that statement there in itself is 100% of a true statement. Roughly 15, maybe closer to the 20-year mark ago, I was working on an installation where we installed heat pumps for the installation in San Antonio, Texas, and the refrigerant was R22. That winter, when the heat pumps were put into the heating mode for the trainees that were out at the campsite that they were installed at, these heat pumps were installed in tents for a tent city type of setup. The heat pumps were not able to keep up with the freezing temperatures in San Antonio that winter. So we were called back out in order to install supplemental heating strips, electric heating or resisted heating, in order to supplement the additional heat coming from the heat pumps. So 20 years ago and beyond, and before that, the refrigerants that were available to heat pump systems were not able to provide adequate heating beneath freezing or anything under 32 degrees Fahrenheit, which made it very hard to use heat pumps in colder climates or regions. So today's heat pumps, your more common air source type heat pumps, are able to meet that need and are slowly being integrated into more applications over the years and are becoming requirements in certain states. Now, both water source and ground source heat pumps are considered geothermal. The geothermal ground source or water source heat pumps, they do achieve higher efficiencies by transferring the heat between your house and the ground, or if you have a nearby water source, some sort of a well, you can use in order to pump that water into your system, so that way you can have that process working for you within that heat pump. Now, geothermal systems can reduce your energy use by 30 to 60%. They control humidity, they're pretty sturdy and reliable, and they fit in a variety of homes. But There are some drawbacks to using this source or this type of source of energy for your heat pump systems. A couple of examples of why is that the geothermal systems are location specific. So it requires locations where the geothermal energy is readily available. Also, it is an expensive resource to tap into for any type of smaller applications, and you run the risk of triggering earthquakes when you are working or looking to install these systems. So you want to be very aware of the foundations that you are working with in order to acquire this energy source for your heat pump systems, whether they are water source or ground source when dealing with geothermal. But do remember that your air source heat pumps are the most common type of heat pump that you will find today in the field. Now let's take a look at some of our heat pump applications in HVAC and some different settings. Now shown here on this slide are some examples of the heating comfort applications that you'll find in residential, multifamily, and also commercial settings. If we take a look to the left, we can see here we have a residential ductless mini split heat pump, which is installed on the outside of a home. So inside of this heat pump here, you're going to have the condensing system or the evaporator system sitting outdoors, and the inside unit that is going to provide your heat somewhere inside within a utility closet. Excuse me, a utility closet. So this would be considered a split system because it's two pieces. Over to the right, you have the
Hey, Lester, we've got
Yes.
a question here in the chat, you know, kind of related to the previous slide and this topic. I've heard that air source heat pumps need double the heating elements in order to heat in colder weather. How does that affect the efficiency?
Double the heating elements. I would need that individual to explain a little bit more. When you're dealing with these air source heat pumps, and depending on the application, which you have HVAC and domestic hot water, if you're dealing in primarily HVAC application, it's going to be strictly a gas or vapor compression type of cycle within the heat pump system. Unless you have backup resistive heat strips or auxiliary heat applied to that system, which typically is an additional component when you purchase a system.
I was just thinking that, Lester. I was thinking the same thing. I was like, I don't know that heating elements, but if you're talking about backup, especially with commercial heat pump water heating systems, yes, for the backup, electric resistance is a good option because then you're still decarbonizing, like you're not using carbon resources, a natural gas boiler, but you do have those in the background. But I was under the understanding that in commercial systems, you always have backups. Like that's just, if you have a huge building, you want to make sure there's hot water running all the time.
Yeah, that's why those temperature maintenance tanks are, and I think you go over that in domestic hot water.
We'll talk about it. And Eric, I see you asking it. I would tell you that when the electric resistance is running, when that has happened with commercial heat pump water heating systems, it does decrease the efficiency. That is the least efficient way to run these systems. You want the heat pumps to cycle effectively as often as possible to meet whatever the design intent is. But if you have to run those backup pieces, then yeah, it like decreases the efficiency. Oh, and Eric goes on to say the Mitsubishi mini splits don't heat below 30-ish degrees, and they offer heat boost units that I was told have more heating elements to allow heating at lower temperatures.
Yeah, so if I believe what's going on is that if you, like I said, you purchase a heat pump, depending on what you're purchasing it for, residential or commercial, they do offer additional packages for auxiliary heat, and the reason they sell that is because it's dependent upon region. If you're in a colder region, you more than likely want to pick up that auxiliary heat package. It's actually recommended. But if you're in areas that don't really reach that freezing or below setting, or regions that are like that, you're pretty much okay with, especially with today's heat pumps. That story that I spoke of about San Antonio a couple years ago, the heat pumps that we currently sell on the market today would have satisfied that requirement 20 years ago. But it took so much time for technology to improve and get to the point that we're at, because it's all due also to the refrigerants and the manipulation of these refrigerants inside of these systems, which is why we're now able to drop the operating points of these heat pump systems down to almost -20 degrees Fahrenheit. I think we go over some of those in our domestic hot water once again systems. But I would say with your HVAC systems, once again, the systems currently on the market, they should be able to satisfy, depending on what you're looking at. Not all of them are there yet. This is still developing technology, but there are systems out there that are able to provide heating down to -20 degrees Fahrenheit. And we could provide some of those applications for you if you need to know what they are at some point during our presentation today, but we'll look into it together.
Yeah, I was actually just thinking, why don't you keep going, and in the background, I'll find out a little bit more about this.
Okay, that sounds good, Kristy.
Perfect.
Yeah, so we are on HVAC applications, and as we were just touching base on, you have your residential systems, which are split heat pump applications. And also those can be combined with cooling as well. So you can have them with solely just heat pump or heat, or you can also get the combined system, which contains that three-way valve we spoke about earlier. And what that does is it's able to switch your vapor compression cycle and just reverse the process, so that way you can have either heating or cooling within that system. Over to the right, you have your multifamily systems that these systems are pretty much the same as your split systems that you'll use on your residential units or your residential homes. But these systems are installed outside of a multifamily building, and each of the apartments or dwellings inside of that building has its own system. So you can also install your split systems inside of these multifamily setups or multifamily buildings, where you can also provide heating and or cooling to that space, which is needed. And then to the very right, what you're looking at within the caged area here are the VRF systems. And someone asked earlier about the VRF and what that stands for. Excuse me. Stands for Variable Refrigerant Flow System. And these systems are created for commercial applications, much larger spaces than your residential or your multifamily systems. And what you're looking at to the right there in that commercial picture is the Skokomish Tribal Community Center. Kristy and I had the opportunity to visit and look at this VRF system that was installed here, which does provide heating, cooling, and the domestic hot water for this entire site. So I think we talk a little bit more about these VRF systems here shortly. So let's continue, and we will get a little bit more deeper into how those systems work. So not only do we have heat pumps for our HVAC applications, we also have heat pumps for our domestic hot water applications. Over to the very left here in the utility closet, you can see a heat pump water heater or unitary heat pump water heater, which has all the components installed inside of it for your vapor compression cycle, which provides you with hot water from one singular unit. So yeah, over to the left, we have our heat pump water heater. And this looks similar to your gas or electric water heater as far as design, with the exception that you may have some ductwork plumbed into the system for any type of air issues that you may have within the space. But if your space is well ventilated and you have no need or use for the ductwork, you don't have to install it. And this water heater can work as a standalone on its own. But sometimes due to the space where it's installed, it's very little airflow and you need to draw it in from a much more richer source. You would install these flexible ducts into your system, which will allow you to do this. Over to the right, you have once again your multifamily setting, and this in this case would be for domestic hot water. And this is on a multifamily setting here. You can see these systems, the outdoor systems, gang together for this multifamily building. And these heat pump systems that you can see here are connected together to a central system that collectively serves 56 units in a multifamily building. So you can purchase the, I believe these are Sanco 2s if I'm not mistaken. Let me double check here so that way I am not saying the wrong thing. Yes, these are the ganged Sanco 2s heat pumps at the Elizabeth James house. And these systems are ganged together in order to provide the volume or total volume of domestic hot water that's required for this building or site. Either during peak loads or off-peak loads, the system is designed to support this, especially with this ganged factor where you can add additional units if need be. And then to the very right here, once again, we have our commercial kitchen. But we also, when we talk commercial, not only kitchens, but any type of commercial applications, you will find domestic hot water heaters, the heat pump hot water heaters in that application. So this image to the right that we're looking at here shows a commercial kitchen from Vermont. And if you look up here in the upper right corner, you will see a heat pump system that is used to provide domestic hot water for our commercial kitchen. And for those of you that have worked in a commercial kitchen or a large kitchen of some sort, a community kitchen, the use of hot water is extremely important to not only create the foods that will be used there, but also for cleaning purposes as well. So if we can find a way to save energy and costs by using these domestic hot water heat pump water heaters, that would definitely help out with our application there. And I just want to mention, just for some quick statistics on these domestic hot water heat pump water heaters, the heat pump used in the commercial kitchen and in the multi-family is the Sanco 2 heat pump. And these heat pumps are capable of producing hot water down to -20 degrees Fahrenheit. And the water temperature being delivered can be up to 175 degrees. So the system in itself uses CO2 as the refrigerant, and this is a ozone-friendly refrigerant, very high on our list of refrigerants. We do have a chart that we'll go through, and you will see exactly what we mean by that as far as the refrigerants that are eco-friendly and those that are not. So that is our domestic hot water applications or heat pump applications for both HVAC and domestic hot water applications. Now, what's coming up next in the world of heat pump systems? And once again, if you look to the left here at our image, we have hybrid VRF systems. And these hybrid VRF systems are starting to gain a lot of traction in the commercial world. They are very adaptable, easy to install, and they offer flexibility in its operation, or flexibility for the application that you are trying to install your system in. And that boils down to a lot of different factors, whether code becomes a factor for a specific system that you're wanting to install, but maybe due to the refrigerant in that system, you can't install it in the space due to regulations and code because you have that space being occupied by, it has human occupancy. So you have people that are in that room, and due to the amount of refrigerant lines that are running in that space, you're unable to install that system. This is where a hybrid VRF system may be able to come into play. And all this boils down to coding and regulations, and whether or not the place that you're trying to install this system is going to be okay as far as regulations for you to install it. So hybrid systems are offering a wide range of flexibility options for function and support in these different types of HVAC or even domestic hot water or hot water heating water or hot water applications. Over to the right there, you'll see plug and play domestic hot water systems. And these systems are starting to be packaged together. And I've seen this engineered out in the field. Several countries I've deployed to work on chiller systems where they have what's called a modular unit. And the modular unit consists of a, it sounds weird, but it's a master and a slave configuration. And the systems that you will start to see in this plug and play domestic hot water heat pump systems is the same types of configurations, where you have a master system which does all the controlling of all the other systems, and slave components which are ganged on top of those systems in order to provide more capacity for the space that you're looking to provide hot water for. And that's in case you add an addition to the building or the site for that application. I am going to take a quick break here, or stop here, pause here really quickly before we move forward. Kristy, do you have anything?
I was thinking we can, so we have an activity planned next, and it could be a good thing to pair with like a coffee or a bathroom break. How do you feel about that?
I like that. We could maybe do 10 minutes with the Comosh Tribal Community Center. Yeah.
I think so. Yeah. So let's move on to the next one. So Lester has been showing you a lot of like really interesting applications and kind of like the background speak around heat pumps. And we want to round it out with like, let's go check something out. Let's go see this in action and see how it's going. So what we have up on the screen is a QR code, and Jordan, would you mind grabbing the link and throwing it in the chat, and make sure you're sending it to the entire audience so that our folks are getting it. But so this is a QR code / a link that is going to take you to the Skokomish Tribal Community Center. And it is a cool building. One, it's just gorgeous, like it's a beautiful center. But two, they had some really specific goals when they built this community center. They wanted to be, they wanted a very small carbon footprint, and they wanted to be net positive. And since the build of this, they have achieved that with solar arrays, with really, really efficient heat pump technology. This QR code / link in the chat will take you to an interactive tour. So you can actually walk through the building and see it. You can go out back and see where the heat pumps are on their concrete pad. There are videos in there where you get to hear the lead engineer who designed it speak about the design decisions he chose. You can look at how it's paired with comfort heating cooling, how it's paired with the domestic hot water system. It's just like overall, you actually get to like see this thing in action. So I think in the next 10 minutes, your task is twofold. Uno, if you need to go and like use the bathroom or grab a cup of coffee, definitely do that first. And then when you come back here, your second task is to go and just explore it. Go check it out. And you have the link now because it's in the deck and you have it in front of you. We can't take that away. So you can go back and explore this even more after the webinar is over and look at it in even more detail. And I think we'll come back together with a question on Slido. Don't ignore the debrief right there, the number 2 in front of you. Ignore that part because we've got a different question on the next interactive poll. But that's how we'll all come back together and continue this conversation. So look at your clock. At 11:13, we'll come back together, get your coffee, explore the community center, and we'll see you shortly.
Kristy, I'm going to leave the Skokomish Tribal Community Center slide up here probably for another 2 to 3 minutes, just so those of you that either left for the bathroom or jumped up, you'll have it here for another 2 to 3 minutes, and then we'll go on over to the Slido question that follows this, so that way we can get those questions answered.
Yeah, love it. Okay, I'll see you shortly.
All righty. I got a lot of work to do. For those of you that need the link to the event or the Slido experience, it is still in the chat. Jordan has placed the link to Slido in the chat, and the thing link is also in the chat as well. So if you need access to the thing link for the virtual tour, please see the chat. And if you need access for the Slido event or active poll, that link is in the chat as well. You can also scan the QR code at the top left-hand corner of the screen, and that will allow you to access the Slido app. See you all back here shortly.
Okay, as you start to finish up your tours and your bathroom breaks, come on back together. This is another Slido, so grab your device or your web browser. It should be still the same place. It doesn't go anywhere, but the code to join is #heatpump. And tell us about your experience going and exploring the Skokomish Tribal Community Center. What was something that caught your attention? And this, you know, if you want to be really technical and on task, you can tell us about what you saw with the comfort heating and cooling or the domestic hot water system. But if you just want to share something that you noticed in the tour, we would love to hear that too. So grab your device, scan the QR code, and let us know about something that caught your attention in your very, very quick tour of the facility. I'm gonna banter a little bit in the background with Lester just so we don't have radio silence going on. Lester, what do you love about the community center? Oh, I had you on. Can you hear me,
There we
Lester?
go.
Okay.
Yep, there we go. I really like the basketball court.
Yeah.
It was beautifully designed. I mean, the entire facility was beautifully designed, but I like to hoop. So that basketball court really caught my eye. But the artwork and the tribal, beautiful.
when we went there, just some like behind the scenes, it was the height of COVID, and so we couldn't explore the entire community center. That was just out of respect. And what we did see, though, it was stunning. So I imagine that entire building is a work of art. Like, and in the first portal, you can listen to the architect talk about the goals and whatnot. Okay, so thank you for that person who chimed in. We'd love to hear more. If there's other folks who want to share what they explored or what they found when they explored, people making the choice to be net zero, low impact. Absolutely, it was a choice. They worked really hard to achieve those things with the design of the building, with the architecture, with the build. I hope, if anything, everyone made it to the back where they can go see the Vrf system, the Mitsubishi City Multis. Sorry, Lester, what were you going to say?
No, I was going to say just that. I hope everyone, especially those of you that are interested in the mechanics behind how these systems work, if you have the opportunity to, if you didn't get it today, do go back in and take the opportunity to go around back to the Vrf systems. You can get more information on those Mitsubishi systems. And then if you head into the basketball court area, you can go to the actual mechanical room where the hot water storage tanks are located. You could find more information on the mixing valves, the heat exchangers, secondary heat exchangers, the maintenance water tank. Everything that's in there has an in-depth review. So I would definitely recommend you, if you didn't get the full experience today, please do go back and enjoy that.
I really like in it, and hopefully, again, like you have now the link and the QR code in the deck, but I like the videos. I thought Morgan Heater, the engineer who did the most of the design work on the system, he was really thorough in his explanations. Like, there is a lot of detail in why they did it this way, how they put it together. I found listening to him talk about it really invaluable. It was like pulling back the curtain to see the great and powerful Oz. Like, oh, that's why that's how, and this is really interesting.
Yeah.
I also want to give a quick call out to Eric, who's been asking the questions about the Mitsubishi stuff. I'm doing some research on it. I'm trying to figure it out. I think I have an answer for you, but I'm not there yet. So you're not forgotten. All right, Lester, I'd say let's move on. Keep on trucking.
All right. Looks like we only had one on this side, so we'll keep it moving. Thank you for that individual that took part in the Slido experience. All right, we're going to pause really quickly, check in, see if Jordan, we have any questions.
None yet, and I know Kristy's researching the follow-up to Eric's. So if there are questions, please do use the questions tab, put them in, and I'll try to field them to our presenters.
Awesome sauce. Thank you, Jordan. All right, let us continue moving along. So now we've spoken to a few of the different applications that you will find heat pump systems in. Now we'll talk a bit more in depth on the heating cooling configurations, specifically to our mini split systems, variable refrigerant flow or VRF systems, and also our monoblock systems. Now, this is not an all-out list here. It's just a starting point to look more closely at some of the form factors in which heat pumps can be used for heating and cooling or comfort heating and cooling. So let's start out with our mini split systems. And mini split systems are really common. One of the more common applications that you're going to find, especially for residential needs. But the mini split systems are systems that could be placed in zones which needs individual control. So in this image here that you see to the right, you have several rooms in this home or this residence, and you literally can have a mini split system installed in each one of these rooms. So you can have different types of mini split systems where you have single or multi-zone uses. And the single zone mini split systems are pretty much designed to cool or heat a single zone or a single room. They typically consist of one outdoor compressor and one indoor unit, which is going to be used to heat or cool that room. And then you have your multi-unit systems, which controls multiple zones within a residence. And unlike the single zone mini split system, the multi-zones are designed to heat or cool multiple rooms or zones within a residence or some sort of a home or space. These systems consist of a single outdoor compressor or system unit and up to 8 indoor units. So instead of having a mini split that is just utilized for one room, you can have a mini split that can be utilized with several indoor systems and one outdoor system in several different zones or rooms within your residence. Now, the great thing about these mini splits is that you do have lots of choices and options for your application. They're pretty powerful as far as heating and cooling loads. They're very efficient, they're quiet, and as far as budget, you can squeeze these into new installations or new residences or even upgrades and find that you are not spending a whole top dollar amount. They
Lester,
are the more common. Mhm.
I was just gonna say, we've got a question that came in on this topic. Does the thermostat need to be set to the same setting, or can they operate independently?
So the mini split systems, it actually is dependent. Uh, there are different systems. Now this is when we get involved into the VRF discussion here. Let me come back to that question on the multi. I know on the single zone, you can have that ducted and it's just one temperature, but on the multiple systems, I believe they work the same way. Don't quote me on that, but there's a variant to that. Let's hold on to that question and we'll come back, because with the implementation of VRF systems, that's when you can actually change each zone and room utilizing only one outdoor unit. With these mini splits, I believe you have to do something completely different in order to get it to where it operates off one thermostat, change the temperature in different rooms. I just don't have experience on that side of the house. But I do know that for the most part, your single zone, you're going to be, especially if it's ducted, you're going to be running the same temperature at every single zone or room that you are heating or cooling. But Jordan, if we can hold on to that question, and then when we come back to a break or questions in this presentation, we'll try to address it a bit in depth, or we'll talk more about it if we can get an answer for our next session on Thursday.
Yeah, we've got some comments coming in. We'll touch on that during a pause for questions.
Okay, awesome sauce. Thank you for that. That was actually a great question, by the way, and we'll definitely look into an answer for that one. Okay, I do apologize. All right, so back to our mini split systems. So with our two types, you have your zone where you have your single and multi-zone, and then you have the different types of ductless systems. So you have your ceiling cassette type, and these are all going to be, I'm going to show you with the red marker here shortly, so you can see exactly what I'm referring to. There we go. All right, so you have your ceiling cassette type, and if you look up here to the very top, that is what's considered a ceiling cassette type. This type of mini split consists of two main components: indoor unit, an indoor unit which is mounted on the ceiling, you can see it up here, and then your outdoor system which is mounted right outside. And this type of configuration is if you prefer your indoor unit to remain pretty much out of sight. You would consider these ceiling cassette type installations. The wall-mounted system you can see here down below. This is a wall-mounted system, a ductless wall-mounted systems. system is pretty popular type of system, mini split system. I've found these types of installations are extremely popular overseas. Worked on a lot of these types of mini splits. Very easy to work on, very easy to maintain. These units are very affordable type of mini split systems, and they work well in all different types of rooms. So if you do need a system that is just readily available, these wall-mounted type systems are great for any type of home setting, residential setting, or even a small office type setting. And then you have your concealed duct installations, which, like ceiling cassettes, which is up here, these concealed ducts are pretty much what you're seeing in most of your residences today. Concealed duct mini splits are also ceiling mounted, where they can connect to other ducts leading into other nearby rooms to provide cooling or heating to those different spaces. And then lastly, you have your floor standing systems, and these units sit on the floor, rest against the wall. And this is another great option if you don't have enough wall space, which goes higher up. So all these different types of mini split indoor are examples of mini split indoor systems. So you have your ceiling cassette, your wall mounted, your concealed duct, which you won't see that at all, and then your floor standing.
And Lester, there's a quick question about what is a ceiling cassette and what does the cassette refer to?
So the ceiling cassette type, it's similar to a fan. If you're familiar with fan coil units, these ceiling cassette types are similar to those. Typically, you'll have piping going into the ceiling cassettes, and what they do is they house some sort of a heat exchanger in some of them, and a filtration system as well. So you have an access to a filter port where you can pull out and clean the filters that go in there. You find these, I will tell you, you'll find these ceiling cassette types more than likely a lot of the time on VRF systems. And the types of spaces that you'll find these ceiling cassette types in are spaces where the facility owner or the individual who wanted the installation requested specifically for ceiling cassette types because of the look that a ceiling cassette type system gives to a specific space. They're a bit more expensive, and that's just once again because of the design factor. And I think we touch on that. We do touch on that a little bit when we get into design factor when dealing with installations of heat pump systems. I think we've got time to really just answer a few more, Jordan, if you want to throw those really quickly.
Yeah, okay, so new question here. Can you please explain how and why heat pumps rely on temperature differentials between interior and exterior temperatures, and why they don't work as well when the temperatures are extremely hot or cold?
Okay, so heat pumps need a source of a source specifically in order to pull heat from. So remember, what heat pumps do is they remove heat from a specific source. So whether that's ground, air, or water, that heat pump is going to utilize that source as the energy where it's going to draw that heat factor from. Today's heat pumps are able to draw heat from some of the lowest temperature points, which makes them very energy efficient and very efficient, period, for the operation, especially in colder climates. And that's due to the types of refrigerants that are being utilized today. So we're not utilizing 22 or 410A within a lot of these systems. We're utilizing CO2 and refrigerants with much lower operating points below freezing temperatures. So that's one reason why we're able to do that. And the second the second part of that question, Jordan, one more time.
Yeah, it's about why heat pumps might not work as well when the temperatures are either extremely hot or cold.
And yeah, that's also due to the design factor of that specific heat pump. Like I said, we've gotten to the point where now we're able to operate heat pumps in lower temperatures. 20 years ago, a heat pump solely on its own without supplemental heating or backup heating or auxiliary heating would not be a sufficient choice for, let's say, New York versus Texas. But we came to find that, you know, that it goes even deeper, because in Texas we weren't able to utilize only a heat pump as a heat source for you know, an outside setup. We were using tents. It was a tent city, but still, you know, just utilizing a heat pump source solely and using that technology from 20 years ago was not sufficient in order to heat those spaces. So supplementing those spaces with auxiliary heat strip backups was able to provide us with the heating that we needed for, you know, all of those spaces, every single last tent on site. But you know, it's like I said, it's all based on the advancement of technology. The refrigerants that are being used today is the biggest reason why we're able to start using these heat pump systems more in depth. Now, here in the United States, we've recently had the authority and authorizations to go and utilize CO2 in our systems, but overseas they're using other refrigerants that are even more energy efficient. We just don't have the regulation to use it here stateside. And these systems have been proven to work in even lower temperatures. So I hope that, you know, I was able to answer that question for the individual that was asking.
Can I add on to that just a little bit, Lester?
Yeah, absolutely, Kristy.
I think sometimes these questions are really challenging because the answer is honestly, it depends. And that is so frustrating, because when you're designing something, you don't need an "it depends" answer. You need a "this is the answer." And so I would keep in mind, I would add this type of framing to that. Heat pumps use the vapor compression cycle, and the efficiency of that vapor compression cycle is dependent on a lot of things. You know, there's a lot of pieces that go into that. One of the considerations is your refrigerant, because as a chemical that is evaporating and condensing, different refrigerants do that. Like, they have a band of temperatures that they operate most effectively at, and then they have beyond that, they aren't very effective. With heat pumps, different refrigerants have different bands of temperatures they work best at. So, and this is exactly what Lester was saying, like Hvac heat pumps, and I'm speaking to heat pump water heaters because that's my expertise for sure. They use R134A. R134A works great at high temperatures, like 50 degrees on, chef's kiss, amazing. But get down to around like 32 degrees and it's not going to be as efficient extracting heat from the air. Whereas like refrigerants like CO2, carbon dioxide, R744, that works really well. Again, 50 degrees onward, chef's kiss, you're going to get great heat extraction. But you start to get a little bit lower and it gets less efficient, but it can at least be efficient down to -20 degrees Fahrenheit. So when you're designing, you have to know that temperature range you are designing for, and then find a product with a refrigerant that meets that. And then think about what's going to go, you know, what are the components of the heat pump that might also affect efficiency. All this to say, it's a complicated question. The answer is complicated, but we can look at there, you know, there's some things you can control in your product selection and in your refrigerant selection. And so that's something to think about as well.
Yeah, absolutely. Thank you for that, Kristy. Everything Kristy said, 100% on point. I always like to tell a lot of the attendees that it ultimately boils down to application, region where you're located, There are so many different factors that are involved. There are refrigerants that are perfectly great to use in certain regions, but it just won't be usable in others, just due to the temperature ranges of its operation. Jordan, were there any more questions that we could quickly answer before moving on?
I just see a thank you from Eric who placed that last question.
Okay, awesome sauce. No worries, Eric. Anytime, please keep them coming. All right, so here we have variable refrigerant flow, VRF systems. And VRF, once again, stands for variable refrigerant flow. And this is exactly how these systems operate. Now, you may be familiar with a term which is referred to as VRV, or variable refrigerant volume. This is just a Daikin brand specific name for VRF systems. And it just is another term that you may hear out there in the field. So you'll either hear VRF, but very rarely will you hear VRV, which stands for variable refrigerant volume. But VRF systems have an outdoor condensing unit, typically one condensing unit connected to multiple indoor systems, as you can see in this diagram here. Variable amounts of refrigerant are piped from the outdoor unit to the indoor units, resulting in flexible load distribution. Now, VRF systems do require a lot of refrigerant to be piped through a building, but they can also save a lot of space that would otherwise be lost by a huge amount of ductwork for traditional hydronic systems. But the refrigerants can pose challenges with code, especially if dealing with a leaking system in an occupied space that could really get you in trouble, or it could halt operation until you're able to find that leak. But the ultimate design of these VRF systems can be flexible and utilize wall sealing or the ducted type of cassette installation for your indoor systems. Now, here's an example of how a VRF system might look and operate in a commercial setting. Over here to the top left, you can see the VRF systems the outdoor units sitting on top of a rooftop. And the reason you're seeing several outdoor VRF outdoor systems here is because you may have multiple units for each one located in this site. So this is probably a really, really big site, which is housing this VRF system. Now, as you can see, I'm going to go over here to the diagram to the right, so I could explain that a little bit better. So typically your VRF system, as you can see here, is going to consist of this one outside unit. And in this installation here, you have 1, 2, 3, 4, 5, 6, 7, 8 units, 8 indoor units. And with the color variations, you can see what type of mode each system is in. So we can look at this and say that this reddish type of color here is going to be heating. So you have some occupants within these zones that would like heating instead of cooling within their space. So with this VRF system, you're able to do this or provide that to these different zones. Due to the variable refrigerant flow operation that happens inside of VRF systems. Also, you can see in this visual here that this type of setup is utilizing the cassette type, it looks like, cassette type setup. And this is, once again, it's just a really compact, nice packaged way to deliver that mode of cooling or heating that you're looking for that zone or that space. Down to the bottom left here, you've got your wall mounts, just a visual so you can see what that wall mount looks like. And once again, your ceiling cassette type, you can see that right here. Now don't get that confused with this drop that's sitting over here to the very left. All this is a diffuser with flexible duct connected, and typically these types of systems here are referred to as hydronic systems. This right here, your cassette type system, is typically a system that is associated with your VRF systems. Ooh, a little bit too fast. All right, so we just got through with your VRF systems. Let's talk a bit about the monoblocks. Yeah, and your monoblock system is a comfort heating cooling system where all the ingredients or the components of the system is packaged together inside of a single unit or a box. And it's similar to your heat pump water heater we spoke about earlier. That's situated in the utility closet where all the components are put together. And these may also be called or referred to as package terminal heat pumps. Now, monoblocks are great options for your multifamily buildings or buildings that have several zones with individual heating or cooling needs. And you can typically have these systems mounted on the wall, ceiling, or floor, and it requires ventilation to the outside of the building. So really quickly, as far as configurations are concerned, we went over the configuration of the mini split system and how that system is configured with an outdoor unit and an indoor unit. You may also have various types of mini split systems when it comes to zones, where you can have single zone or multi-zone systems. And these systems still operate with one outdoor unit, but either, depending on your application, once again, one to several indoor systems. We touched on variable refrigerant flow and spoke to that as far as having the option of having different mediums within your zones as far as heating and cooling operational at the same time. You can get this type of configuration by utilizing a VRF system, variable refrigerant flow system. And then lastly, we spoke to monoblock systems, which are self-contained units that can provide you with heat pump options where you can have your heating and cooling through utilizing a monoblock system. Now let's pause for some questions here really quickly. And I'm not sure if we do, Jordan, but if we don't, what we're going to do is go into next, because we are running a bit short on time, our heat pump essential code considerations.
Yeah, maybe I would just mention this comment before in response to does the thermostat need to be set to the same setting or can they operate independently? And there's a comment here, multi-zone systems have separate thermostats on each mini split in each room. I saw that in some of the images. I know we kind of touched on that in that whole section of the presentation just now.
Okay. So someone did comment and say that the on the mini split multi zones that you can adjust temperature for each room.
Yeah.
Okay. That's awesome. You know, like I said, I hadn't had the opportunity to work on an installation of a a mini split multi-zone system. But you know, due to the way that that system is designed, I'm not sure how it operates. I'd have to look more into it. But it sounds very, very similar to a VRF system. And VRF system and VRF technology is really, it's actually been overseas for years, but it's very new here in the States.
And Lester, here's one new one too. For the monoblock, is there a vent to the outside? No heat exchanger needed outside?
No, it vents directly to the outside, so you have to have it installed on a wall, which has some way of evacuating outside. So typically when they're installed, you'll find these installed near windows, and or like near or under, like I've seen them mostly installed under windows in like very nice housing or hotels. That way they can create the exhaust for it directly behind that wall.
Thanks, Lester.
Yeah, absolutely. All right, so we are nearing the end of our presentation here, and it looks like we should have time to cover our heat pump essential code considerations. So let's jump into that if we don't have any further questions. So heat pump code, heat pump HVAC considerations. We will talk a little bit about design footprint, space planning, and also types of refrigerants. So you want to get the most out of your heat pump comfort heating and cooling system. And there are several different steps that you want to take into account or considerations that you want to take into account when you are looking at having one of these systems installed. And that is your design footprint, your space planning, and also the type of refrigerant that you'll be using. The footprint is just the clearance and location of the outdoor system. Planning ahead for spaces planning is just planning ahead for distances and heights needed for different components as far as your installation, operation, and also maintenance. And then refrigerant, you want to keep in mind this is part of the safety and code requirement. It has a lot to do with ASHRAE codes 15 and 34, which we'll look at a little bit more closely. So considerations when looking at design footprint. Once again, you have your ceiling cassette, wall cassette type outdoor setup here, and also your monoblock system. You'll have your installation coming in several different forms or different types of installation designs. But when you're installing these systems, you want to make sure that the installation is neat and orderly, or even well hidden. But could take on a couple of other factors specifically to the individual that's requesting this type of installation. Now, as you can see here, you have your ceiling wall, your ceiling cassettes. You can see that a bit more in detail, how that look and what types of settings that you would find your ceiling cassette installed in. Here's an example of your wall cassette, and this looks like maybe a studio apartment or some kind of a condo. You would have this wall cassette type here, and it's just the system sitting on a wall, different design. Your outdoor heat pumps, these are staged outdoor nicely. The installing contractor did a very nice job of installing these outdoor heat pumps on these type of rack settings on the exterior of the building or facility. And then finally, your monoblocks, a detailed view of what that looks like. And you can have your monoblock situated on another part of the room, but you have to find a way in order to exhaust the airflow that needs to be exhausted so the system could work and operate correctly. So that's all part of the design factor, and that'll boil down to your contractor and whether or not they have the capabilities to make that happen. So everything you see here on design footprint is about aesthetics. Next, you have your spaces planning and how much space you want to dedicate to your system, your indoor air system. And here in this slide deck, you can see this is a large facility which is utilizing hydronic systems for heating and cooling. As you can see, there's a cooling tower sitting up here. Looks like a Liebert unit down here, and a chiller system possibly potentially here, and several mechanical rooms with air handlers located here. So what you're going to find is that you can save a lot of space in a facility this big by utilizing, instead of a hydronic system that utilizes cooling towers and chillers and air handler units, you can install a Vrf system, which would just pipe directly into each one of these office spaces utilizing a cassette type or even a wall-mounted indoor system. And all these spaces here for your mechanical rooms can be converted now into nice real estate that you can use for the rest of your facility for other reasons or uses. So your planning phase, whether that's in the initial or fresh construction, or even if you're going through some kind of renovation and upgrades, you want to consider how much of your real estate is available for that specific system.
Lester, we've got a quick question about the monoblocks. This might be related to the previous slide.
Mm-hmm.
Is the monoblock entirely inside, or is the compressor on the outside of the wall?
No, all the components on the monoblock is installed inside the system. Now, I'm just going to mention this, and it's way off topic, not really, but kind of sort of. You'll find in refrigeration, when you're talking to like an ice box or a walk-in freezer, you'll find your compressor sitting outside of a system similar to that monoblock type setup. So you will see refrigeration systems like that. And a lot of the time they keep the compressor on the outside to keep to keep the heat out, and then also your condensing system is located right out there as well. So it's really close together, but it's like sitting right outside, mounted right outside the ice box or the walk-in refrigerator. But those are the only times I've seen a setup like that. Yeah, but not on a monoblock that you'll find inside of a residence or a commercial setting. If that was it on the questions, we have refrigerant considerations. And here on this diagram that we're looking at on this slide, you can see several refrigerants from R32 up to R17 that are going to be better refrigerants to utilize in your systems. And as we go down this list here, you can see refrigerants that are worse off, ranging from R134A, down to R12. And these refrigerants that you're seeing on the worst side are becoming to be, or if not already, are becoming phased out after a certain date. And some of the refrigerants that you may see up here, okay, so they moved it already. 410A is down here so far. So 410A is one of the more used refrigerants in the field today, especially in residential applications. And it was the ultimate replacement for 22. So you can see that both of these refrigerants are already getting, well, 22 is already on the phase out list, but 410A is probably on its way there next, if not already. So these refrigerants are worse to utilize, bad, high GWP, global warming potential, but these refrigerants moving up here are from R32 to R717 are better for the environment, and also more common refrigerants that are being used today in order to save energy and also cost. Now, I just want to point out, you can see here we have R744, Kristy spoke about earlier, CO2, but you also have R717 ammonia and R290 propane. I know propane is not being used in the United States currently, but ammonia and CO2 are the two refrigerants that are being used and are offering and showing very low GWP potential, or GWP, when in use.
Lester, there's a quick question about refrigerants. Are refrigerants released into the air during regular operation of the heat pumps, or is this only in the event of an accident or spill?
It's only in the event of a leak. So once you have some sort of, once you've lost integrity in your line set, and basically that just means you have a pin-size hole in that line set or anywhere in the system where you have the ability to leak refrigerant from it, that's when it becomes an issue. But when the system is in operation and it's installed and also piped correctly, you should not have any leaks within your system, because you're using solder and copper tubing a lot of the time in order to put these systems together from the outdoor to the indoor unit. So these should be tight, leak checked, and pressure checked at at the recommended levels in order to put that system in operation. So you should never have any release of refrigerant when your system is in operation.
Thank you.
No worries. All right, so that's refrigerants there. So you want to stay on the better side of the list, and if you still have systems that are holding refrigerant or utilizing refrigerants that are towards the worst side, you want to look at getting some sort of a conversion for that system, so that way you're within regulation, and also you're not out of luck when you're unable to purchase that specific refrigerant. I know right now R22 in itself is very hard to get if you still own an R22 system. I know a lot of people on the East Coast have them, but they're calling that liquid gold right now. I think R22 is running close to $1,000 for a 30-pound jug. All right, so that's refrigerant right now. We have just covered. So once again, when dealing with the installation of your system, you want to look at your design footprint, make sure you have the space available. And if not, there are options out there for you to have that system installed. But mainly you want to focus on your regulations and the type of system that you're looking at installing. Spaces planning, just planning ahead for the installation operation, and also the maintenance of that piece of equipment. I know, working a lot of commercial work, and 10, 15 years ago, the engineers that installed a lot of these systems installed them in ways where you couldn't even do maintenance on them. Talking about installing the system or having it drawn up and installed backwards, you can't even access the filter port to change the filters because the system was installed backward. That may not always be an engineering design, but there is a QA/QC process, and someone should have caught that. And maintenance does not get done when a technician finds that type of setup, because you're not going to be able to get in there in order to pull that filter out, because there's no way of accessing the filter access port. So very important with spaces planning. And then finally, keep in mind refrigerants is an important part of your safety and code requirements. And this has a lot to do with ASHRAE 15 and 34, which we'll look at more closely here shortly.
Actually, Lester, I was going to suggest a pivot, and we can let our learners know we always overplan. Like, that's just our go-to. We want to make sure we're not sitting here with like 30 minutes left and like, oh, we said everything. We have a lot to share with you, and there's a lot out there too. And I would suggest, just to be respectful of time, because we're at 11:57, we skip right to slide 47, which is our last, like, hey, check your understanding, provide us some feedback slide. And then we revisit some of these pieces next time we're together. We like to include case studies, which is what you were just looking at. We like to include some talk about code, which is what we're like lightly stepping over. And again, just to be respectful of time. So what we would love as we kind of wrap up here, rather than like rushing through some stuff, is if there are questions, final questions, post them in the chat, because we can stay and answer those for sure. But if you're like, all right, it's noon, I'm out of here, before you head out, if you could let us know how we did. This is another quick interactive survey to check your understanding. There's questions like, what is a heat pump? Let us know if we met the objectives we set out for ourselves. And also, there's space for you to provide us feedback, things that worked really well, things that you'd like to see next time, ideas for the future. We take the things that you write here really, really seriously. So if you have the next 2 minutes to quickly go through the couple of questions there, we'd really appreciate it. And we'll be just like generally bantering in the background, so it's not dead silence.
Yeah.
We would really appreciate any feedback you can provide today.
Definitely. I do like the energy of today's course. Lots of questions, yeah. And that's a good thing. I do want to assure. Oh yeah, I think it's a great thing. I do want to assure everyone that we do have just a few more slides to cover from day one, but we will get to those on day two. We have a brief review that we'll do. We'll cover that, and then we'll go through the rest of what we have remaining today on Thursday, and then do our brief review. So that way you have the full content that we're delivering to you today.
Yeah, we won't just like toss it out, not the baby with the bathwater. We'll just come back to it. It's just it's super pet peeve of mine when we're like trying to rush at the very end, because by then I'm checked out. So I assume everyone here is like ready to go. So survey, and then you're welcome to leave. And please join us again on Thursday, where we will spend some time talking, like wrapping up and then talking more about heat pump water heaters. I know, great energy today, right?
Yeah, it was high. It was up there. I liked it a lot.
Yeah. And good questions. I
Great
did
question.
find out about that. I'll talk to you offline about that question that Eric had, because we'll come back on Thursday with an answer for that. I found out some things that were really interesting, and then some things that I just couldn't figure out yet. Like I
Okay.
can find the refrigerant for this, which I think is part of the answer. So yeah, as you are heading out, if you could fill out the survey, we will see you again on Thursday to talk more about domestic hot water and heat pump applications. Make sure, remember that Katie asked you fill out the survey that they send you so she can get feedback on this and continue to get funding to offer these classes. And it's officially 12, so you are welcome to leave. And thank you so much for attending today.
Thank you to both of you. That was a great class. As a reminder, Thursday's class, if you're not registered for it, lightingdesignlab.com, and go get the link for that.
Same time, same place. We'll be here talking about heat pump water heaters. Woo!
Oh yeah.
Yeah. I'm kind of glad we had so many good questions, and that happens when you get really, really good questions. So like you.
Yeah, I was gonna say, yeah, we've had sessions like this where it's been really interactive, and you know, we'd love to be on time with all the content, but we'd also like to, you know, get our learners to their questions answered. So, you know, I want everyone to leave feeling full.
You know what I appreciate about webinars like this with the learners that we have who are amazing is that they we didn't hit our time goal because we were looking at things together that were really important, versus like when you're in a classroom with teenagers and they're like, it's snowing outside, and you're like, cool, no,
Yeah.
we're gonna get through this lesson, we're done. Right.
Right.
Like we didn't get done because we had really robust conversation.
Absolutely, and that's what helps. That's what makes you understand this material. So, great job with those questions today.
And I'm so happy we had 6 people fill out our survey, our check your understanding. That is awesome.
Yeah.
Yeah. So I'm thinking, Lester, tomorrow when we do like our check-in meeting, we can attend to this and make sure we get the content into Thursday too, so that it's not neglected.
Absolutely.
Cool. Cool beans. We'll wait on for like another minute more while people finish up and log out, but you are welcome to leave. Thank you for hanging out with us. Super appreciate it.
Yes, thank you, and we will see you all back on Thursday, same place, same time.
Yeah, so here's what I read about that Mitsubishi split system that with like the extra coils. It has something called an H2I. That's what they're coining, like their technology, just like Sanco too, right? But it's just an inverter-driven compressor, so it can really, really precisely meet a zone's needs. And I think they're using, I can't find the specs for it to say what their refrigerant is, but it sounds like to me they're using carbon dioxide, because they're saying it will operate efficiently down to -5 degrees. No, wait. It operates above 100% efficiency down to 23 degrees Fahrenheit. And then it will operate at about 76% efficiency down to -5 degrees Fahrenheit. So to me, that is, I mean,
sounds like CO2.
Yeah, that's the closest I can think to it, but I want to find it on paper first. So like paired with an inverter.
That's what I'm about to say.
Yeah.
Paired with an inverter-driven compressor, you've got, yeah. You should have something that could take you down that low, and is that a water heater or an actual AC system?
No, it's a Mitsubishi mini split system.
Oh, it's a mini split. Oh, okay.
Yeah, and they have residential sizes, they have commercial sizes, they have like somewhere in between multifamily sizes. It's an interesting product, the M series. So I'll keep investigating, but yeah, it was.
Like I always say,
the coils came from, except maybe in the vapor compression cycle, maybe like on your
Yeah, the coils, that threw me off. I know, these systems nowadays can come with these inverter driven compressors, and then it boils down to, like you said, that refrigerant factor.
Yeah, exactly.
What have we got in there? Is it CO2? And if it is, you should be dropping pretty low.
Mm-hmm. I do wonder, so I didn't read anywhere about where its release is at. So if it is a purely Asian European product, it could be propane. They could be using ammonia.
Now, the one I would say, if it had to be, it would probably be ammonia. The propane, I don't believe we're using it stateside yet.
Okay. It looks like Matt just confirmed he shared the product CO2. I think, is that right, Matt? I'm looking in the chat. Yeah. Oh, I'm going to copy. Thank you for sharing the hyperlink. Yes, CO2.
Was it CO2?
Oh, so right. It is
Nice.
CO2.
Look, you got it.
I mean, that's awesome. I'm totally gonna go look this up. I want to know more about. I mean, I don't know. Learning about the products to me is really interesting because ultimately, like, that's how we do the thing. So you need to know what's on the market.
What's on the market, exactly.
Yeah. Thank you, Matt. Super appreciate it. He says it's not sure of its availability in the U.S., although I read something about Mitsubishi and Train partnering. Yeah, I think Mitsubishi
They're doing a lot of work. I believe they have some systems overseas that are, in operation. So it's slow to come to the U.S.
Yeah. Okay, I think that's about it for us. Thank you everyone who hung out to the end. We're gonna go ahead and end the webinar, but it was wonderful spending some time with you today, and have a great episode.
Yeah.
Thanks, everyone.
All right. Bye.
Bye.